Okay, so today we're going to be talking about finding the diagonal of a three-dimensional rectangular shape or a rectangular prism. So in order to do this, we're going to use the Pythagorean theorem. Hooray! So just remember, Pythagorean theorem is a squared plus b squared equals c squared, where the two smaller sides squared added together equals the longest side squared. Now looking at it, I need to somehow solve for this diagonal that goes from this front corner all the way to this back corner of this shape. Okay, it gives me the measurements that I need to find the volume of the cube. It gives me the width, the length, and the height. But remember, in order to use the Pythagorean theorem, I would need to know the legs of the triangle. So if you think about it, if I want to do the Pythagorean theorem on this diagonal right here, it goes from this front corner to this back corner, I would need to know this length, which I do. It's the height, right, which is just 2. So I need to know that length right there. But the other leg would be the line that would go along the bottom of this rectangle. That's not very straight, sorry. That would go along the bottom of this rectangle. Okay, so those two would form the leg for this diagonal that's going three-dimensional space right here. So I don't know this length. I don't know this diagonal length right here. Okay, but I do know that the width is 3 and the length is 7. With that information, that should form a right triangle right there. Can I figure out that length? Yeah, just use the Pythagorean theorem. So basically what's going to end up happening is I'm going to have to use the Pythagorean theorem twice. I'm going to have to use the Pythagorean theorem to find one leg of the triangle that I would need to solve for the diagonal of the cube shape here. So let's go ahead and set it up so that I can solve for this three-dimensional shape here. So let's solve for this bottom leg first, this 2D version of the 2D line here. Basically, it's just going flat along the bottom of the prism. Okay, so I have 7 and 3. So it'll be 7 squared plus 3 squared is going to equal, we'll call it, well, I guess I could call it what it actually is, FH squared. Okay, because that's the line that goes from F to H. Okay, so then I square, I get 49, and I get 9 equals FH squared. Add them together, and I get 58 is equal to FH squared. Now remember, the last thing we do on every Pythagorean theorem problem is we have to undo all the squaring we just did. So to undo a square, we do our square roots. Okay, so square root of 58 is going to be 7.615, blah, blah, blah. Just going to round that to 7.6. So again, you square root, and you're going to get 7.6 is equal to FH. So that's this line right here. So this line is going to be 7.6. Okay, now that I know that, I have my two legs, right? I have 7.6 and 2. Now I can use that to solve for FD here, FD. Okay, that's the line that goes from the front of the cube to the back of the top of the cube. Okay, so again, I set up the Pythagorean theorem. I get 7.6 squared plus 2 squared equals FD squared. Okay, then I square them, 7.6. Now this is where we're going to get slightly inaccurate because I don't have all these numbers that I initially had, but that's fine. It will be approximate. It won't be exact. So 7.6 squared plus 2 squared. So hold on, let me just do 7.6. Sorry, I jumped a step. So 7.6 is 57.76, and then 2 squared is 4, is equal to FD squared. Add them together, you get 61.76 is equal to FD squared. And then the last thing we do is square root. And the square root of 61.76 is going to be 7.858, blah, blah, blah. So we're just going to round that to 7.9 is the measurement of FD. Okay, so this diagonal that goes from here to here is approximately 7.9, whatever measurement they're using. It doesn't say, but 7.9 would be the measurement there. Okay, so basically that's all we're doing with the 3D shapes is we have to find the flat diagonal that goes from front to back to get one of the legs. Because basically what I'm doing is I'm taking this little slice out and just making it a two-dimensional shape to solve for that diagonal. I'm taking that leg, the height, and then the diagonal there. Okay, let's look at another example. So spider has taken up residence in a small cardboard box, which measures 2 inches by 4 inches by 4 inches. So that means the width is 2, the length is 4, and the height is 4. Okay. What is the length in inches of a straight spider web that will carry the spider from the lower right corner to the upper left back corner of the box? So again, same idea. I need to solve for this length of the spider web here. I know the dimensions of the box. What I don't know is the length of one of the legs. I know that the height is 4, so I know this length of the triangle is going to be 4. What I don't know is that bottom leg that would go from there to there. So again, I'm taking this diagonal triangle, basically. It's a diagonal triangle inside the box to solve for the spider web. Okay, so again, I need to solve for this line first. So again, I know the width is 2. I know this leg is 4, so I can do the Pythagorean theorem. 4 squared plus 2 squared equals, we'll call it x squared. So this is x. Okay, then we square them, add them together, get 16 plus 4 is equal to x squared. Add them together, you get 20 is equal to x squared. And then you find the square root of 20. And it's going to be 4.472 blah, blah, blah. So we're going to round that to 4.5 is equal to x, just x, sorry, because we square rooted everything, and the square root of x squared is just x. So this line right here is 4.5, approximately. Again, we round it. Okay, so then I know this length is 4, this length is, or this length is 4, this length is 5. I can then use those to figure out the diagonal of the spider web. So it'll be 4 squared plus 4.5 squared is going to equal, we'll call it W for web, W squared. Okay, so 4 squared is 16, 4.5 squared is 20.25 is equal to W squared. Add them together, I get 36.25 is equal to W squared, and the last thing we do is square root. And the square root of 36.25 is going to be 6.02079, blah, 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 blah. So we're going to round that to 6.0, or just 6, I guess. So the length of this spider web is going to be 6 inches, right? As it was in inches. It gave me the measurement of what it's in this time. So the web is equal to approximately 6 inches long. And that's all we're doing with 3D Pythagorean theorem. You're just solving for a bottom diagonal and then use that with the height to figure out the diagonal of the box of the shape there.